Hi, hello guys, welcome back to my channel. It's always nice to have you guys here so that we can learn together. So this is the sixth video in this series. We've been learning machine learning, right? And we've learned a lot. So if this is the first video that you are watching, maybe you saw the video online or it popped up in your feed, I will encourage you to go and watch the first video and watch like everything incrementally so that we can you can get the full gist. So in today's class we're going to be looking at logistic regression. So like 2 videos ago we learned about linear regression. We wrote our AI model, to use linear regression to make some predictions, and the last video we looked at multiple regression, and we were able to use multiple regression to do like a kind of weather forecast, right? So in today's class we're going to be looking at logistic regression, and I think that you guys will learn a lot. So the first thing that we always do is to kind of have like a recap of what we did last week. So last week we looked at multiple regression. Like I said, we define it and see the difference between multiple regression and multiple linear regression and just linear regression. We did some examples, then we wrote a model for weather forecast. So if you have not seen it and this is your first time, please go and watch that. And then we did some hands-on activity to test our model. I think you guys should be able to see this. So test model with values. Okay, sounds good. So now let's go through what we have today. So today we're going to be defining what logistic regression is about. Okay, so it's very simple. Okay, and I would make sure to make it really simple for you guys, and we have code. So like we're going to also look at the relationship between linear, multiple and logistic regression, so that when you have a problem or you have something that you want to create, like use AI to solve, you'll be able to know whether you need multiple regression, linear regression or logistic regression to solve that problem. Okay, so I'll try to explain that to you guys. Then we're going to look at example of logistic data, regression data. Then we're going to be designing our logistic regression model, and I think you guys will like this one because the code that we're going to be writing, we're going to be writing code to predict if a patient is likely to have diabetes or not, and we are using real clinic data, right? This is exactly the data that the scientists use, in the labs and all of that, when you go to doctor and all of that. So you guys are the real deal. So we're going to teach our logistic regression model. Then we're going to have some hand-on activity, okay, to teach our model, to test our model, right? Then I also have some, like I have 2 homeworks for you in this video, right? So I think you guys will love it. Okay, so let's just get right into it because of time. So what is logistic regression? So we define linear regression, 1 input 1 output, right? We define multiple regression, multiple input 1 output, but they are all linear. So now what is logistic regression? Sorry about that. So logistic regression is a statistical model, like our method, yeah. So like all of the regression stuff, they are from statistics, okay, used for binary classification. Okay, so binary class, so like a binary is either 0 or 1, right? So when I say binary classification, it means that it can be used for classifying for something that has 2 values, okay, which means it is used to predict probability of one of 2 possible outcomes. Okay, I'll give you my example that you will be able to relate to it. So a type of regression, so is a type of regression analysis used for binary classification. Is the same thing. It predicts the probability of a binary outcome, right? So the output of a logistic regression is always 2 outputs, either true or false, 0 or 1. What was showing there? Yeah. So Okay, so unlike linear regression, which predicts a continuous outcome, okay, so for linear regression, it gives you continuous outcome. I'll explain that. Logistic regression predicts a binary outcome that can only take on two values, typically 0, 1, yes or no, true or false, pass or fail. This last one we are explaining. So in our example of baby height, okay, so linear and multiple regression will predict the height of the baby, right? So linear regression or multiple regression will say, oh, based on the age of the baby, then the height of the baby will be like 3 feet, 4 feet, 6 feet, so the output is continuous. You can have different outputs for multiple and linear regression, but for logistic regression, since the output can only be two, so the logistic regression can only say the baby is tall or the baby is short, right? So you see the difference. Logistic regression can only give you two outputs, right? While multiple regression, well, let me say that again. Logistic regression the output of a logistic regression can only be two values, right? Either the baby is tall or short. The output of linear and multiple regression, is continuous. The baby can be 2 feet, 3 feet, 4 feet, and baby of 6 feet. I don't know, so you see it's continuous, right? So that's the difference between the two. So now, when to use logistic regression? So now that we know the definition, when do we use it? So for example, for medical diagnosis, right? So when you go to the hospital, then they want to okay, so when someone goes to the hospital and they want to diagnose the person, if the person has diabetes or not, or cancer or not, or anything, you see the output is two. It's either you have it or you don't have it, right? So they use logistic regression for something like that. Another example is credit risk assessment. So if the bank want to borrow somebody money, right, and they want to know if the person is credit worthy, meaning that the person will return their money or not, right? So they want to know, they have their model, probably logistic model, to predict if they give the person money, will the person return the money or not. You see, the output is two. And then for spam email detection, in your Gmail, there is a section called the spam email, right? So Gmail, so like some people send spam email to you, like for ad and all of that, and Google has some algorithm to say, oh, this email is spam email, this is not spam email. Then if it's spam email, put it in this folder, right? So the outcome is either the email is spam or not. So that is logistic regression. Another one is insurance policy, right? For risk assessment, if somebody want to take home insurance or car insurance, right? So the insurance guys will look at the person's information, like get all the inputs, history, and say, can we give this person insurance, or not, based on the like the record of the person, right? So that is also two, either we can give him or not. Then the last one that I have is to predict if user will click on advert. So we have advert on YouTube and all of that, so you can write a logistic model to say, oh, based on all of this input, will user click on the ad or not, right? So the output is also two, and that's logistic regression. So just like to explain further before we start writing code for logistic regression, because I don't want this video to be too long, right? But I still want you guys to understand what logistic regression is. So we know that linear regression takes one input and predicts many outputs, right? Okay, so yeah, so the linear regression take one input and predict one output of continuous outcome, right? that's what they're supposed to say. So but we have a picture here, the one that we did before. So let's assume that this is a linear regression. It takes the age of the child and it gives us the height of the child. That's one output, but the one output can have different values, outcome. The baby can be 3 feet, 4 feet, 2.5, 0.5, you know, it goes to infinity, you know, like no matter, you know, like the age of the baby is. So for multiple regression, remember we can have multiple input, and then also the output is 1, and but that output can have different values, right? So you guys follow, right? Then for logistic regression can also handle multiple input, or one input, or 1 million input. It doesn't matter, right? But the output, you know, is also the height of a child, right? But it can only tell you if the child is tall or short. That's all. It's binary, it's 2. You know, the value of the outcome of the output can only be 2, tall or short. Okay, so let me see, I think that's all I have for this slide before we go into the coding. All right, so hopefully you guys were able to understand what logistic regression is, right? Then for people that are much more that want to know advanced, right? So the graph of logistic regression is gonna look something like this. So if you don't understand it, that's fine, right? It's like a sigmoid function, right? For people that are much more advanced, right? So this is how the graph is gonna be. Then this is gonna be 0, then this is gonna be 1, right? And then the probability of something being 0 or being 1, or in between. No, this is for logistic. Then we know for multiple linear regression is straight line, but since it's multiple, so we can have many, you know. So for example 1 2 3 4, so 1 2 3 4, right? Then for linear regression it's just gonna be 1, right? So that's how to draw the graphs of linear regression, multiple regression, logistic regression, if you are interested in that. But you really don't need to focus more on that. Okay, so let's go and write code for a logistic regression. So I'm gonna put a text in here. Now let me remove this. Okay, I can do it, then I can move it up. Okay, so I can put it. So we're going to write code to predict diabetes using logistic regression. Okay, so we have data like from I downloaded the data online, but it's like a real clinical data. Okay, so the data give us information about patient and give us whether they have diabetes or not, right? So using that data we can write a logistic model that can predict based on some input, based on the medical history of a patient, to say if the patient is likely to have diabetes or not. Okay, and I think that you guys will like it. So the first step, of course, you know, is to get our data. Okay, so I have the data. Again, I will put the link in the description so that you can get the data. So I will upload mine in here, and it's diabetes.csv, again, not CVS. Okay, so where's that? There it is. So let me just close this for better view. Again, I'll copy and paste the code because I don't want the video to be long. The last video was like 40 minutes, so I want to try to make this 30. Okay, so again, since that we that we, so like libraries that were written for us already that we can use. Make sure that you write everything correctly. I had to write mine, okay, so but I don't want to write it again, right? Okay, so just click on that. If you type everything correctly, everything should be green. So let's write another line of code. So this one is just to ignore warnings. Like, it's not needed though, but it's just to avoid seeing some unnecessary warnings, you know, in our when we are running our code. Okay, so you can write this, you know, just run it like nothing will happen. Okay, so now let's load our data and kind of see what is inside. So when we load our data, which is in sample data folder, then we'll call this .s. So like this is just going to show us a preview of our data, so like 5 data point, you know, from each. So when I run this, it will load the data using pandas. Okay, and it's going to show us some values, you know, and let's see. Okay, so let's look at this for a second. So these are all the values that we have in our data. You see pregnancy. So like pregnancy means that is the person pregnant and how long has the person be pregnant. So if 6 months, 1 month, 8 months, 1 month, or if the person is not pregnant, then it's 0. Then the glucose level of that person, the blood pressure, the skin thickness, the insulin level, the BMI, I think body mass index, right? Then diabetics pedigree function. This one is it measures the history of diabetes in the person's family, right? So if they used to have diabetes or something like that, right? So this is what this is for. Then of course the age. Then the outcome is whether the person has diabetes or not, right? So this data is just like data that is being collected from like hospital, right? Based on the information that they have on patient, right? So we have a lot of it, right? So the idea is, well, if you have this data about a lot of people, and it's like we're able to get if they have diabetes or not. Okay, so we can use that data to train an AI to say, oh, if you have all of these, then you have diabetes, right? So if you have all of these, then you don't have diabetes, right? So it's a way to learn from data. That's what AI is all about. Okay, so let's add one more about to just get information about the data. So this one is just gonna give us some information about the data, and then this one I just added it to remind myself that because I didn't know the meaning of this, I had to Google it. Okay, so diabetes based on family history, that's what this is about in the data, right? Then we can see, so we have 768 data point. Again, in real life application, you probably need like up to like 100,000 data point, but just because we are doing testing, right? So 768 is good, you know. Then we have all of that. We can see they are all integers, right? But this one are float and float. If you don't know what, so like, okay, let me explain. Integers are whole numbers, right? In your maths, integers are whole numbers. Then float are decimal numbers. Yeah, yeah. I think that makes sense. Okay. All right. So let's do one more thing, just for statistics sake. This one will just describe the data set to give us, you know, the number that we have is 768. The mean, so like pregnancy, like the mean of pregnancy is 3.8, so like meaning 3.8 months, but that's not 3.8 months. Standard deviation 25%, you know, is 1 month pregnancy, 50% is 3 month pregnancy, and all of that, blah blah blah, right? So all right, okay, so let's continue. So the next thing that we want to do is to get the correlation. I told you guys about correlation in the last video, is to see how the variables affect each other, right? So because what we want to predict is the outcome, right, whether the person has diabetes or not. So we want to see how are other variables affecting outcome, like the outcome, right? So for us to trace that, so we can say outcome to pregnancy. Oh, pregnancy is affecting it by 0.2. Oh, not that much, but glucose is affecting our outcome by 0.46, right? So what this is saying is, when we design our model and we are testing, right, and we want to change the values of some variables, right, so the value that we can change that will cause like our outcome to change very fast is the one that has the highest correlation, right? So that's one thing to note, right? So the outcome with blood pressure is like 0.06. So blood pressure doesn't really affect it. Skin thickness, insulin affect it a little bit, 0.1. BMI affect it a lot. Diabetes, pedigree function, a little bit. Then outcome to outcome is going to be 1, because they're just comparing both to each other, right? So hopefully you guys get the gist from that one. So the next thing that I want us to do, so is still the correlation, but just to put it like in a very fancy diagram. Okay, take your time to write this to so that you can see how, so you see how cool. So it's just the same thing as this, but put in like in a very cool form, you know. So you see, comparing outcome to pregnancy, outcome to this, you know, and then you have this nice looking design, you know. You don't have to do it, but you know, it's cool, right? So that's for that. But again, just to know the relationship between the variables. Okay, so now since we have our variables, right, so we need to define our input and our output. And so, you know, our output is outcome, right? So we need to put our outcome in one variable, then put the other ones in a separate variable. And to do it is this. Okay, so this is our input, right? So we are saying our input and these are the data. So we are saying drop outcome, so meaning remove outcome from the data so that we can use this as our input. Then our output is just take outcome, right? So after running this, our x will be all the input except the outcome. Our y will be the outcome. Okay, so nothing to show there. Then we continue. Then this next one is just to scale our input. Okay, just write this code like this, right? So we scale, so our x is now being scaled. So let's put another code. So now the next thing is for us to split our data set into train and test. You know, we should all know this by now. Okay, so we have our data, which is the x and y, right? Input and output. Then we want to randomize them, and then we want to test size is going to be 20%, and train is going to be 80%. That's good, nothing to show. We are almost getting there. So okay, now we are going to train our model. Okay, so remember the last time that we did this, we said our model is called to linear regression, right? But this one is logistic regression, and this logistic regression, maybe you didn't notice, is what we imported from here, right? So it's part of our model. So it's just like an empty AI. Just imagine like an empty brain that we need to teach. That's what it is. So then, so this we declare the empty brain here. Let me even pull it. Declaring an empty AI brain, because that's what it is. Then we train it in here. Okay, so now we have it. So I think the next thing is to check the accuracy of our data. Okay, so let's do this. So this one will check the accuracy, then this one will do a prediction. We are going to use this y predict down. I will explain why we need it, but this is everything that we need to check how accurate is our model that we're training here. And again, you see that we use train x and y to train it, then we are now using x test and y test, right? So what this is actually doing is, okay, now we've trained our model, so now our model should now predict what the values, like the output of this x test will be, and now compare it with y test, which is the true result, right? So let's see. So our model is 82% accurate, which is not bad. Okay, so there's something called confusion matrix. Okay, this one is just to kind of say how our model is predicting, like what did it predict wrong and what did it predict right. Okay, there's gonna be a visual representation of that right now, and I will show you guys what that means. So our confusion matrix, so again, write this one the way it is, so you will see what this is. Okay, so this is saying that these are all the true labels, right? Out of labels that are zero, like meaning like not diabetic, right? So we predicted 98, right? And we predicted some to be 1, so that means 9 is wrong, and 98 is correct, right? Then for the one that has diabetes, right, 29 is correct and 18 is incorrect, right? So this is where this is even like is biting us that we are not that accurate, but again, it's just 82%, and it's still pretty accurate to be honest, right? It's over 75. So but that's what confusion matrix is how confused our AI is, right? Like our AI is confused like 9 times, but not confused 98 times for predicting not diabetic. Our AI is not confused 29 times for predicting diabetes, but confused 18 times. All right, so hopefully that's clear. Now we want to test our data, like test our AI with new data. Okay, which is always fun, because that's when you guys will kind of play with the data, right? So let's say the person has 1 month pregnancy, glucose level is 5, blood pressure is 80, skin thickness is 28, insulin level is 127, BMI is 20, diabetes pedigree function is 2, then the person is 60 years old. Will the person be diabetic or not? Let's ask our AI. Oh, our AI said the person is not diabetic. Okay, so let's just assume that the person's glucose level is 55. Let's see what will happen. Oh, the person is diabetic. Okay, so you see, glucose level affect whether the person will be diabetic or not, right? So let me even try this. Let's say the age is 20, it's still diabetic. Then maybe this is also 30, reduce a little bit, it's still diabetic. So let's see which one affected more. The insulin, let's say insulin is 30, it's still 1. I guess the glucose level affected a lot, still 1, it's still 1. Let me try this, still 1. Maybe the insulin level is affecting it in the reverse direction. Let's see. Yeah, okay, I see. Okay, so this one is reverse direction, but yeah, I mean, you guys get it gist. So the homework that I have for you guys is gonna be a little bit more than we usually have. Okay, so but I think you guys will be able to do it. Okay, so of course the first homework, you know, is just for you to practice, right? Is for you to test the like this with different values, right? Just play around with it, but make sure that you play around more with inputs that have high correlation with the outcome, right? The glucose level, you know, the insulin, the BMI, you know, the age, right? If you play more with skin thickness or blood pressure, it won't affect it that much, right? So just giving you guys clue. So that's for that one. Then the second assignment, it's kind of long, but it's not coding, right? It's just for you guys to understand the concept, right? Let me see if I can copy everything from where it is in here. So give me a second. Okay, all right, so I have 10 questions for you guys. Okay, oh, I think I didn't copy the the question itself. Let me copy the question itself. So the question is, assuming that you are a business owner or you're a programmer and you have a client, and the client gave you this project to work on. So like these projects, right? It should be projects, right? Then use this project's requirement to decide whether to use linear regression, multiple regression, or logistic regression, right? So you guys remember the difference between linear regression, multiple regression, and logistic regression, right? So I want you to read through this, and so like you don't have to type this back to me, just say one, say logistic or linear or multiple. Okay, so you know what, like I will do this one for you guys. Okay, so a real estate company want to predict the selling price of houses in a particular city based on their size. So what type of regression will you use to predict the house prices and their sizes? Okay, the first thing that you need to think about is what are the inputs and what are the outputs, right, of this model, right? So the value of the output, will it be just to maybe like true or false, or maybe sell or not sell? No, if that's the case, then that's logistic, right? But if it's a continuous value, right, so many it can be anything, then that means it's either multiple or linear regression, right? So, and we can see we want to predict the price of the house. The price of the house is not high or low. No, it's going to be continuous, maybe 50,000, 100,000. So it's definitely not not logistic regression, right? But then remember, in here the input is going to be based on just the size. They are not considering anything else, it's just the size. So it's one input, one output. So the answer of this one is linear regression. So you tell the client, oh, I know what to do, I'm going to use linear regression to help you solve your problem, right? So that's one of it. So I've solved this one for you. So I want you guys to read through all of this and kind of tell me whether it's logistic, multiple, or linear. And again, you don't have to type all of this, you know, just put the value, say one, this. And for people that are not part of my class and are just watching this video online, you know, because I have a class that I teach, you know, or some people, so you can just put your answer in the chat, right, to say, oh, one is this and this and that, right? So okay, I think we are at the end of this class, and I think we are at the end of regression actually. So we're going to be looking at models that are not linear, because logistic, linear regression, and multiple regression, they are linear models, right? So I think next class is going to be really interesting. Again, thank you guys so much for watching my video. It's really nice to have you guys here. Please don't forget to like my video, subscribe, and share. I'll see you guys in the next video.